Good morning and welcome back to the next class of Theory of Computation. In this class, we are going to compare a deterministic finite automata with a non-deterministic finite automata. A deterministic finite automata is related to the word determinism. Consider a girl studying in 12th opts for maths as subject. This shows that she is determined to do engineering as a graduation based on the score in 12th. Similarly, a non-deterministic automata is related to the word non-determinism. Consider another girl studying in 12th opts for math as well as biology. This girl gives her chance to appear for engineering or medical as a graduate. So she is not determined to do engineering or medical field. So similarly, a deterministic automata on any particular state based on a particular input can transit to a fixed state every time. Whereas in case of a non-deterministic finite automata, in a particular state based on a particular input, the automata may transit to one or other state. There are multiple options for transition. In case of deterministic finite automata, there is only one choice. Whereas in case of non-deterministic finite automata, there are multiple choice and any one choice can be selected at random. Transition for all inputs on each and every state is must in case of deterministic finite automata. Whereas transition may be for some state, some inputs in a case of non-deterministic finite automata. It is not necessary to show all transition on all inputs for every states in the non-deterministic finite automata. Deterministic finite automata is defined by 5 tuple as m equals to q sigma delta q0 and f, where q is finite non-empty set of states, sigma is finite set of input symbols, delta is the transition mapping given by q into sigma derives to q, q0 is the initial state of the finite automata, and f is the set of final states. Similarly, a non-deterministic finite automata is also defined by 5 tuples as q, sigma, delta, q0 and f, where q again represents the finite non-empty set of states, sigma represents the finite set of input symbols, delta is different in case of non-deterministic finite automata. It's again represent the transition mapping which is given by q into sigma derives to 2 to the power q, which represents the power set of q. Q0 is the initial state of the finite automata and F is again the finite set of final states. Here, these are the differences between deterministic and non-deterministic finite automata. Even though with these differences, deterministic finite automata and non-deterministic finite automata are equally powerful in terms of the language they accept. Thus, DFA and NFA both have the same power or equivalent power. But DFA can be considered to be more efficient than a non-deterministic finite automata in terms of its time efficiency in recognizing a string or generating a string. Thank you. In the next class, we are going to look at some examples on design of non-deterministic finite automata.